Hi everybody, my name is Chris Flores and I'm happy to present you this poster, which is the result of one of our group's works. It's titled PFC Analysis of a Carbon Nanotube for Absorption of Ibuprofen, Carboxyibuprofen and Hydroxyibuprofen. Emerging pollutants such as personal hygiene and pharmaceutical products represent a great risk to our health and the environment. Their presence is well identified in different bodies of water. Ibuprofen and two of its main metabolites, carboxyibuprofen and 2-hydroxyibuprofen, have attracted attention with ibuprofen occupying third place in the world for its use as an anti-inflammatory and painkiller. In this work, an analysis of the absorption of the mentioned molecule on a carbon nanotube is presented using density functional theory, DFT. We propose the system as a potential alternative for the removal of pollutants and wastewater from domestic use in hospitals. Ibuprofen is the third most used analgesic worldwide and is also found in wastewater. Two of its main metabolites, carboxyibuprofen and hydroxyibuprofen. Several studies have shown that ibuprofen can be absorbed on the surface of both multi-walled carbon nanotubes and single-walled carbon nanotubes. Mechanisms by which ibuprofen absorbs on multiple carbon nanotubes are hydrophobic effect interactions, pi-pi interactions, covalent bonding, hydrogen bonding, and electrostatic interactions. In this DFT study, ibuprofen molecules and its metabolites were selected, as well as chiral carbon nanotube 5,6 with doping of a silicon atom. Analyzing absorption energies and parameters related to them, through these populations, it was observed that a silicon-doped carbon nanotube presents the highest absorption energy towards the absorption of carboxyibuprofen. Simulating a system of carbon nanotubes decorated with silicon using density functional theory, this study will allow interaction tests to be carried out to propose a possible elimination system for the metabolites of ibuprofen. Hydroxyibuprofen or carboxyibuprofen present in wastewater by determining the parameters by which said absorption is carried out. For the methodology, all calculations were carried out using the Gaussian 16 program. To create the systems, we took into consideration different positions of approximation in the nanotube for carbon metabolites, considering distance of 1.96 angstroms between the atom of silicon and the surface of the nanotube, and each of the oxygens present in each metabolite. The geometry optimizations and the vibrational frequencies for ibuprofen and its metabolites carried out with a functional B3 length base set 6311 GT and 4 carbon nanotubes with silicon and carbon nanotubes, silicon and metabolite system with the same functional but basis set 631 GD. All energies were calculated with the functional B3 ellipse and the basis set 6311 plus GDP. For the results, the optimization calculations and vibrational frequencies allowed us to observe that the structures correspond to true minima. The infrared spectrum results show a shift in the wave number for both the metabolite and the silicon carbon nanotube, both in reference to the nanotube metabolite system. The smallest displacement is obtained for the carbon nanotube carboxyibuprofen system for both carbon-hydrogen bond and carbon-silicon bond. On the other hand, for the same bond, the greatest displacement is observed in the nanotube 2-hydroxyibuprofen system. No changes were observed for carbon-carbon bonds in the system mentioned above. For bonds corresponding to the oxygen-hydrogen group, for three molecules, that is ibuprofen, 2-hydroxyibuprofen, and carboxyibuprofen, decrease in the wave number was noted. The 2-hydroxyibuprofen being the one that presents the greatest difference when measured before absorption and after absorption. while ibuprofen had the lowest displacement for the hydroxy group. For the frontier orbital surfaces, in the case of HOMO and 2-hydroxyibuprofen, the greater expansion of the surface occurs for the silicon atom, carbon nanotube, when the molecule is absorbed, which is observed in a similar way in the nanotube system, carboxyibuprofen. For the nanotube ibuprofen structure, this HOMO surface extends towards the ibuprofen. In the case of LUMO orbital, there is a similarity in the distribution for the nanotubes that absorb and metabolize 2-hydroxyibuprofen and carboxyibuprofen. LUMO surface of carbon nanotube with ibuprofen was not very different from the other two absorption systems. The HOMO-LUMO energy difference in the carbon nanotube carboxyibuprofen system was lower, with a corresponding value of 1,855 electron volts when compared to that of the nanotube before absorbing any molecule with a value of 1,748 electron volts. On the other hand, the largest HOMO-LUMO energy difference corresponded to the nanotube ibuprofen structure at 1,909 electron volts. It is also possible to observe in the absorption system ibuprofen is the molecule that has the smallest interaction surface with the nanotube, since it has relaxed perpendicularly with respect to the nanotube. The highest absorption energy is found when carboxyibuprofen is absorbed by the nanotube at minus 38,278 kilocalories per mole. Although both the absorption of ibuprofen and 2-hydroxyibuprofen are not very far from that of carboxyibuprofen, at minus 33,258 and 35,768 kilocalories per mole, respectively. From these values, it can be predicted that the absorptions of the molecule under study present covalence features. The absorption of ibuprofen and its metabolites is possible through the use of carbon nanotubes of silicon, with the highest absorption towards carboxyibuprofen. The above can be observed to represent greater absorption energy. It is also possible to denote a smaller change in reversional displacements as well as in HOMO-LUMO energy. Thank you so much for your attention.